Hello and welcome to the video. Today we'll be doing another separation method for differential equation series, and in this instance we're going to find the general solution of this equation here. So using the method of separation, I first want to write this under dy and dx form x. That'll be beneficial for our purposes. So rewriting the equation, I have dy over dx in place of y prime, and then I will copy over the right hand side. After this is done, the next step is to separate all the y's and all the x's, because I want all the y's on one side, all the x's on the other side. So to do that, I'm going to multiply this side by 1 over y so that it cancels on this side, and I have to do it to the other side. So I have a 1 over y on this side, and then I will also multiply by dx, and then multiply by dx. Cleaning all this up, I have a 1 over y dy on the left hand side, and these y's have canceled, so now I have a 3x over 5 plus x squared, and then I have my dx multiplied over from this side onto the other side now. And after this step, I now have all the x's on one side, all the y's on the other, and so now I can integrate. So integrating both sides. The left hand side, remember, just 1 over y is the basic integral, which is natural log of absolute value of y. And then if we go to the other side, it looks like we have to do a u substitution in this case. So I'm going to let u equal to the bottom, which will be a 5 plus x squared. And then I need to find my du, so taking the derivative gives me just a 2x and a dx. Now I don't have a 2x on top, so what I'm going to do is just get dx by itself to make it simpler. Okay, so now after I have dx by itself, so I have dx is equal to du over 2x. Now I want to clean this up a bit and substitute in what I need so I know what to cancel out. So I have a 3x still, I haven't done anything with that. On the bottom I set that equal to u, so I can plug a u in there. And my dx I found was du over 2x, so I can plug in a du over 2x in place of dx. Now if we notice we have an x on top and bottom, so those will cancel out. And then I have a 3 over 2, which a constant value can be pulled out of an integral. So I'm going to have 3 over 2. And I am left with 1 over u du, and that's equal again to our natural log of y. And then integrating this, we get 3 halves, just stays. Then we have a natural log of u, but don't forget a plus c. And you could have put the plus c on the other side as well. It doesn't really matter just as long as it's there, because you do need some unknown constant when you take the integral. And then now I'm going to plug u back in to get everything in terms of x and y again. So let's see, 5 plus x squared plus c. And then if I wanted to find, if I wanted to get y by itself, what I can do is I can take it to the exponential power, because e to the natural log is just whatever is inside the natural log. So I'm going to bring this power up, so it'll be 3 over halves, because that's another rule of logarithms, you can bring powers up or down. And I will take the e of everything here. So what I'm left with is a y equal to 5 plus x squared. And this will be to the 3 halves power. So we moved that power up and then took the exponential. And then this will just be another constant, just plus c. And the reason it's just plus c is if you think e is basically a number, it's just like 2.71 some continues. And if you take it to the power, c is just some unknown number. So a number to raise to some number is just another number. So we can just write it as c. And then that is our general solution.